friends, today I am going to discuss about the interest formula for discrete compounding. Usually there are two types of cash flows. That is, the first one is a single cash flow and other one is a uniform series or the uniform cash flows. So in this session we will discuss about the single cash flows. There are two single cash flows. The first one is a single payment compound amount and second one is single payment present worth. So in the single payment compound amount, to find future value f, that is compound amount, how to calculate, where the present value or the present investment is given. The equation is 1 plus I to the power n, that is f equal to p into 1 plus I to the power n, that is it is nothing but the compound interest. So in the discrete interest factor table, the factor symbol used is f by p I percent n. Whereas single payment present worth, where present worth to be calculated using the given future value. The equation is p equal to f into 1 by 1 plus I to the power n, and the factor symbol in the discrete interest factor table, it is p by f I percent n. Let's see the example. Here for the first formula, that is single payment compound amount. A person deposits a sum of rupees 20,000 at the interest rate of 18% compounded annually for 10 years. Find the maturity value after 10 years. That is, at the end of 10th year, what is the maturity value? That is future value. If you deposit now, that is the present value. In this case, so this is a cash flow diagram. Cash flow diagram. Here, cash outflow is negative, that is present value you are depositing. Cash inflow is a positive, the upward arrow. The present value, it is 20,000 rupees deposited, 18% interest rate annually compounding, n is number of years. The future value f equal to p into 1 plus I to the power n, or so from the table, okay, discrete interest factor table, so you can refer the 18% interest rate and n is 10 years, that is in the 10th row, and the table of 18% interest rate, okay, p into f by p I n. So that value is 5.234. Therefore, if you multiply this to the present value, present worth or present value, then it will be 1,04,680 rupees. It is nothing but, if you deposit 20,000 now, after 10 years you will get 1,04,680 rupees at 18% interest rate. This is a single payment compound amount. That is, single payment series is only once at the beginning and at the end of the your interest period, the cash flow takes place, either cash inflow or cash outflow. Okay, only once the cash inflow and once cash outflow. That is only at the beginning and at the end of the interest period, so the cash flow takes place. Second one is single payment present worth. Okay, so here the present worth you have to calculate. So if future value is given, f is given, and the present worth you can calculate. For example, a person wishes to have future sum of rupees 1 lakh rupees, that is rupees 1 lakh at the end of 10 year, okay, for his son's education after 10 years from now. What is the single payment that he deposit now, so that he gets the desired amount after 10 years. After 10 years, he need 1 lakh rupees. How much he should deposit? Only at the, only once. Okay. The bank gives 15% interest rate compounded annually. Here future value is 1 lakh rupees and I equal to 15%, n is 10 years. So in this, the present value have to calculate, P have to calculate how much you should deposit to get 1 lakh rupees at 15% interest rate. Therefore, P equal to f by 1 plus I to the power n. Or this compound discrete interest factor table, P by f I n. So this table, so that is f into 1 lakh into this factor, okay, 0.2472, that is 24,720 rupees he must deposit now in order to get the 1 lakh rupees after 10 years at 15% interest rate. Okay, these are the two single payment your interest factors or the interest formula. So one is a single payment present worth and the future value.